Hey mathletes, here we are looking at section 2.6, and our goal today is to be able to use angle properties to prove geometric relationships. All right, so first, remember that you will have your page number in the red for your student journal through these notes, so you can follow along and take notes with us. So on page 59, you'll see this proof. So what we're looking at is, again, remember the structure of our proof. So here we're kind of looking at a different structure than a two-column proof, but a flowchart proof. So notice our beginning statements are going to start kind of to our left, and as we move right with our arrows, we'll get to our conclusion. So as we start here, notice our given statement starts on the furthest left. So here we have our statement B that's given. Okay, AC equals AB plus AB. Well, we're going to use two statements to kind of build this next one, so that's why we have two arrows going to this next step. So we kind of want to conclude, where are we getting these? So our conclusions are being what we're writing in. Okay, so AB plus BC equals AC. Well, that's our segment addition postulate. Okay. So now from those two things, we should recognize that they're both equal to AC. So by the transitive property, they can be equal to themselves. So now that we have AB plus AB equals AB plus BC, well, notice we have AB on both sides, so we can subtract both AB from both sides, and we get our conclusion that AB is equal to BC. So that's kind of gives you an idea of what a flowchart proof will look like. We'll do a couple of those here today. So again, we're just matching here the reasons with the corresponding steps. So here we have this diagram, okay, where angle 2 is kind of in between angle 1 and angle 3, and angle 1 and angle 3 are congruent. So what we want to prove, given that 1 and 3 are congruent, we want to prove that angle EBA, so this angle, is congruent to CBD. That makes logical sense, but we want to be thorough with it. Makes sense because if 1 and 3 are equal and we're both adding 2 to both angles, then the addition of those angles are still going to be equal as well. So measure of angle 1 equals the measure of angle 3. So again, we're just going to look in our bank over here, and we're going to say that is a given statement. Okay. Next, we see that angle EBA is angle 2 plus angle 3. Well, that's our angle addition postulate. We could use A or B, but I'm just going to check off A first. Okay. Next, what we see is that we have the measure of angle EBA equals the measure of angle 2 plus the measure of angle 3. So what's changed is that this is now the measure of angle 1. And we can do that because we know that the measure of angle 1 equals the measure of angle 3, and we can substitute that in. So the substitution property allows us to do so. Okay. Going from that step to this step, we see not much is different, but we have just flipped the order here of addition. Remember from algebra that if we're flipping order of addition, that's our commutative property. Okay. And then before we get to our proof statement or our conclusion, we see we have the measure of angle 1 plus the measure of angle 2 equals the measure of CBD. Well, that's again our angle addition postulate. So that is D or A, depending on how the order you choose to do that. So now, both of the measure of angle CBD is equal to the angle 1 plus angle 2. Measure of angle EBA is equal to the measure of 1 plus the measure of angle 2. So therefore, by our transitive property, we see that those two measures are equal to each other. Okay, so there's another example of a kind of flowchart proof as we work here. Okay. Some theorems that we're going to go over today. One is our right angle congruence theorem. Okay, it just states that all right angles are congruent. I went ahead and posted this proof here. You can see it on page 61. Okay. So if we have angles 1 and angle 2 are right angles, okay, we want to prove that they're congruent. So this is kind of nice because we can see and compare and contrast the difference between our flowchart proof and also our two-column proof. Okay. So our given statement, angle 1 and angle 2 are right angles. Okay. Notice we see that here and here. Okay. Next, we're going to say, well, what does it mean to be right angles? Well, it means that the measure of angle 1 and measure of angle 2 is 90 degrees. That is the definition of what a right angle is. So notice we see that there and there. Okay. Well, again, if we see things that are both equal to 90 degrees, 90 degrees here, 90 degrees here, then they must be equal to themselves. We can see that in our third step, and that's using, again, our transitive property. And the last piece is just saying that, well, if they're equal to each other, well, then they are congruent. And we can say that because the definition of congruency. So you see where that lays there in our two-column proof. Okay. Our next theorems that we're going to look at, we'll only look at the proof of one of them. The other one is very similar, but we're just saying congruent supplements theorem. So here it's saying that angle 1 and angle 2 are supplementary. Angle 3 and angle 2 are supplementary. Then we can conclude that angle 1 is congruent to angle 3. So angle 1 is congruent to angle 3. All right, and that makes sense since 1 plus angle 2 is 180 degrees, and angle 2 plus angle 3 is 180 degrees. Well, if angle 2 is the same angle, then angle 1 must be congruent to angle 3. We'll see that proof here in a second. Okay. Congruent complements theorem is the same idea. Angle 4 and angle 5 are complementary. Angle 6 and angle 5 are complementary. So therefore we can see that angle 4 and angle 6 are congruent as well. Okay, so we'll look at the first theorem. Okay, we can put this in page 61 in our notes. Okay, so given angle 1 and angle 2 are supplementary, angle 3 and angle 2 are supplementary, we should see as we do our two-column proof here, our given statement is first. Okay. Well, again, if I see words like supplementary, there's a good chance I'm going to use that definition of supplementary next to make a mathematical statement. As I see that they're both equal to 180, okay, we should be getting a sense of some patterns that we recognize with these proofs that we're going to use our transitive property of equality. Now we have the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. And again, we see that we have the same thing on both sides of our equation. So let's simplify that. Since they're being added, we know that we can do subtraction property of equality to get our next step. And we have the measure of angle 1 equals the measure of angle 3. We might, by the subtraction property, we might feel like we can stop, but remember, we're proving things are congruent. So we have to take it one step further and just say, well, if we know if they're equal measures, then they are congruent to themselves, and that's just by our definition of congruent angles. Okay. So notice, again, our proof statement should be our last statement here, our conclusion. Our given is like our hypotheses if we're thinking about our conditional statements. Okay. Some other postulates that we'll deal with in theorems. Okay, the first postulate is our linear pair postulate. Notice it's kind of it's a conditional statement. If two angles form a linear pair, then they are supplementary. Okay, so we can use this in our proofs now. So if we see that we have a linear pair here, 1 and 2, then we know that angle 1 plus angle 2 is 180 degrees. The other one that will prove to be really useful and valuable for this course is our vertical angle congruence theorem. If we have vertical angles, then we can see that angle 1 would be congruent to angle 3, and angle 2 will be congruent to angle 4. So this is our vertical angles congruence theorem. Oftentimes, we'll just shortcut this theorem and just name them vertical angles, and therefore we know that they're congruent. Okay. Our last proof here, you're going to see on page 63. Okay. You see I have a flowchart proof and a two-column proof. We're just going to focus on the two-column proof. But as you're working, notice the similarities and contract it to the flowchart proof that you have there as well. Okay. So with my first given information, I'm going to kind of take a shortcut here because we know our given information should be our first statement. It's kind of our hypotheses where we're starting out. Okay. And our conclusion, we know needs to be our proof statement. So as I have that, I want to kind of set these up and know that they're going to come into play. Okay. So again, I want to try and have an idea in my head what's going on here. So ACB, maybe colors here, so I have some, so angle ACB plus ACD are supplementary. Okay, so they add up to 180 degrees. Linear pairs make sense there. Angle EGF, okay, EGF is here, okay, and ACD are supplementary as well. So therefore, we want to say that angle ACB is congruent to EGF. Okay, so this is going to look similar to our supplementary angles are congruent theorem. So let's go ahead and try and mimic that. Okay, so if we know that we know that this first thing is given, so we want to include that. So now let's use this vocab word and make a mathematical statement. So we get that the measure of angle ACB plus the measure of angle ACD equals 180 degrees. Okay, and this is by definition of supplementary. Okay. And by the same token, we can say that the measure of angle EGF plus the measure of angle ACD equals 180 degrees. I'm just going to put parentheses here to indicate that it's the same step as before. It's the definition of supplementary. Okay, so since they're both equal to 180 degrees, I can say that the measure of angle ACB plus the measure of angle ACD equals the measure of EGF plus the measure of angle ACD. I think I got a little, forgot my angle symbol there. Since we see that they both have a measure of ACD in them, let's go ahead and subtract that away. So then if we subtract that away, we have the measure of angle ACB is equal to the measure of angle EGF, and that is our subtraction property of equality. As I'm moving over to my statements, I see I forgot to put my reason there. So again, if they're both equal to 180, then we're using our transitive property. And we're getting close there, but again, we're missing our congruence thing. So then we can say that the angle ACB is congruent to angle EGF. And that last reason is because that's the definition of congruency. If they are equal in measure, then they are congruent. Okay, that's going to conclude our notes today on proving geometric relationships.